Hey, I had 2 out of 3 things turned on. That's not good. But look, now there's audio. Hi, I'm John Park. This is John Park's Workshop. Thanks everyone so much for stopping by today. I just need to pause some of the little feedback videos there so I don't lose my marbles. Can y'all hear me out there? Hello to everyone over in the chats. We've got a gang of people over in our YouTube and over in our Discord. Thanks for stopping by. Hey, Dave Odessa and Beatagraf Abdel Hagen and Johnny Bergdahl. Hello. That's over in the YouTube. If you're somewhere where you're wondering where the chat is at, this is the place to be. This is our Discord. Look for the live broadcast chat channel. Where is our Discord? Go to adafruit.it/Discord and you'll get an immediate, instant invite to jump in on all the fun. What do we have now? Like 35,000 or more people involved with this Discord. It's tremendous. And there's loads and loads of different channels that you can check out. As you can see here, this is live broadcast chat, but there's pet photos and there's help with CircuitPython and there's help with projects. There's 3D printing stuff, a bunch of topics like CircuitPython dev if you're deep in on that, and on and on. So go over to our Discord, where you'll find the likes of Andy Calloway, hello, and DJ Mixer C. Hey there. Oh, I like your icon. That's really cute. Johnny Bergdahl is there as well, and Byron, hi. And VP Tech Ops, hello. Thin Man, Jim Hendrickson, Andy Calloway, Paul Cutler, Blitz City DIY, howdy. Howdy, howdy, howdy. So what I've got going on today, I've got a coupon code for you so you can save some money over in the Adafruit shop. I've got a recap of the product pick of the week. I have a new CircuitPython Parsec that also involves some new revised hardware. I have a continuation of the Joystick Fight Stick project, which may evolve into a whole other thing or spawn off another side project. And I have, I think, something else. We'll talk about some upcoming projects. So, did I miss anything? I don't think so. Let's get started. So, coupon code. You want to save some money? Type that in the coupon code slot at Adafruit. When you head on over to adafruit.com and throw some stuff in your cart, if it's physical items that we can send to you, then you can type that in there and get 10% off. That coupon code is caliper. Like, where'd my calipers go? I call them calipers. I don't know why I made the coupon code be caliper singular. I have a very important set of them right here on the workbench. These are, in fact, the ones that we sell in the Adafruit shop, and they are inexpensive, and I find them to be excellent. Have I shown these before? Let me show you these. This would be the full fractal black hole inception of coupon codes to use. These solar digital calipers. I've been using these for a while in the workshop here. I have some fancier ones inside where my electronics bench is, but these right here, they seem terrific. They're $14.95. For you, with that coupon code, let's, here we'll do this. With that coupon code right there. How is it? How big is it? Let's turn these on. That is approximately, okay, there's no actual way to measure this, but at this distance, 155 millimeters. That means nothing. But these are nice, and they are solar powered. I think they have a little CR2016 cell in there. I don't know if it charges that or if it charges a capacitor. I haven't taken these apart. But millimeter, inch, all the usual stuff. Inside measurement, outside measurement, depth measurement, all those standard things on there. And you can zero it out if you need to start, let's say, there and figure out how much bigger that is. So yeah, those are nice. But that doesn't have to be the only thing you buy or the thing you buy at all. Go check out the shop. Check out products. Check out categories. Check out new items. We got these fancy, what's the deal with these? These fancy Raspberry Pi branded flash drives. What's going on there? Isn't there a thing now with people running Raspberry Pis off of the flash drive? Or am I making that up? Is it just with SSDs? Anyway, if you can throw it in the cart and we can ship it to you in an envelope or a box or something like that, then you can save 10% off with that coupon code CALIPER. That will not work on software or gift certificates or subscriptions, but that will work on goods and things and atoms that we can ship to you. So head over to the shop. That is good until midnight East Coast time tonight. Let me move that over. Caliper. That's your coupon code. Hey there, C. Grover. C. Grover just showed up, and there's jokes and puns from Andy Calloway. Thank you. All right. That's what's going on with that. Let's now jump over to a little time travel. Tuesday's show, I have a product pick of the week every week on Tuesdays. I will actually mention I'm not going to be here next Tuesday. I'll be out of town, so there will not be a product pick of the week next week, but there will be the following week. But here's what happened this week. It was this. Here's a little recap. The 0.96-inch monochrome OLED graphical display. These are both I2C and SPI interfaces. We've got both of them on there. And you'll see here, this is something I love to use this kind of display for. A lot of people do. You'll see this used in all sorts of little devices that have a few buttons or knobs or dials, and you want additional UI. Great for crisp little UI with a little bit of graphics, a little bit of text. I'm not trying to do anything fancy on here. Nothing's moving too fast. You'll see here as I press my tactile switches. Back off, turn them all on. So you see it is nice and responsive. It is the monochrome 0.96-inch 128 by 64 OLED graphical display with SPI and I2C over Stemma QT. That was the thing. All right, next up. By the way, that one changed at the last second. We had an issue with a other product I was going to show, a smaller display, the 128 by 32. So we switched to that one. I wish I had a little more time and I would have shown it with SPI. I think it would be interesting. I've never done that, but I'd like to at some point. Maybe I'll do that just for the workshop show next week. Show that exact same display. I think I need to get a second one. That exact same display in both I2C and SPI modes on a capable microcontroller, and just see what's the practical difference. Does anyone know off the top of their head? I think there might be a 4-to-1 theoretical bandwidth improvement, but in practical terms, I think maybe it's twice as fast on these microcontrollers. I'm not sure. Let me know if anyone has characterized that or done any testing. Be curious. Right on. Let's do this. Hey, okay, look, more blinky lights on the CircuitPython Parsec today. I want to show you how we can fill between two buttons on our NeoTrellis display. Now, the core of this will work on any of our Trellis or NeoTrellis driver boards. I've in the past been showing the NeoTrellis M4, which is this one here, built in 8x4, but I put together this Mecha Trellis, which I mentioned on Show and Tell last night, which is the same idea, seesaw board on there, uses all the Adafruit NeoTrellis code, but this uses mechanical key switches, and it's a custom board, and I'll show a link to that after. But on this Mecha Trellis, or on a NeoTrellis, what we have been doing is lighting up different of these buttons when we press them, and I'd also been doing some starburst effects, running hit one and then light up their neighbors. But I'm thinking about putting together different kinds of MIDI controllers and sequencers and things like that. And one thing that can be useful is to be able to launch rows or columns with a couple of button presses. So what I've got right here is if I press one button and then another one, let's do just a short little row in the middle here. If I press this blue button first and then this red button, we're going to fill, we'll start with the blue. We're going to fill that little section from first to last. So I'm essentially specifying two vertices. Let's fill in the line between them. And I have this working on columns and rows, and it ignores any sort of diagonals or things like that. But if I just want to run straight across, then I press two buttons and we zip that color from the first to the last. So how this is working in code, if you take a look in CircuitPython here, I have typical NeoTrellis and multi-trellis setups. This is actually considered to be 4 trellis boards. And so we set that up as there are 64 buttons on here, and I have 4 trellis, NeoTrellis drivers on I2C and their 4 addresses. So I've soldered their little address jumpers so that I have 4 addresses. So that sets up this trellis as a multi-trellis. I'm setting my brightness, I'm creating some color definitions for different colors I might want to use, and also a second little list of a dim version of them. Generally with NeoPixels, it's better to do a dimmer version of a color versus trying to mess with brightness, because that's universal and it's a little slow. So I have a couple of those, and then I have a color table. This just defines the 64 buttons in sort of a friendly way here that I can edit and set the initial colors of these, as well as the colors that they go to when pressed or toggled to bright or dim. And then I've got a few helper functions here. One of them converts my X, Y button positions to the 0 to 63 grid, and this just, I have it going in both directions. So this just helps me call up things that are a big list or point to a coordinate on the grid. Then I have the playback LED colors. This is just what happens when I start up. So if I hit reset here, you'll see the first thing I do is light them all up and then dim them all. So that's just what this playback LED colors function does. Here is the key thing for today, is this fill between function. And this takes in an X and a Y coordinate of 2 buttons. And then what we do is we check to see, are these on the same row, or are they on the same column, or neither? So if the Y1 and the Y2, so that's the first button's Y position and the second button's Y position, if those are the same, then we're going to go ahead and proceed and fill in the rest. So what we do then is take the 2 coordinate points and determine which one is on the left and which one is on the right of those X positions. So that's how I use this start X and end X. Then for that range, we just run through and turn them on. So trellis color, and we set the color to whatever the first button's color was. So yellow or green, whichever of those has been pressed first. Same thing happens in the vertical. It's identical. It's just using Y instead of X. And then we have a little callback here for checking when NeoTrellis buttons get pressed or released, and then we can use those in the main loop here for this little rising edge, falling edge callback. So trellis activate key. What are we going to do? Well, we've pressed a key in the main loop. We're just constantly checking to see has anything changed. And that's standard NeoTrellis stuff. But this is the key thing right here, is just this fill between, which can be useful not just for this type of hands-on mechanical key switch or neotrellis pad, but anytime you want to fill between two objects, you can just loop between those in a column or a row. And so that is how we can create horizontal and vertical effects on our trellis inside of CircuitPython. And that is your CircuitPython Parsec.
CircuitPython Parsec.
Oh my goodness, my audio was off. Thank you. For the last 2 minutes, I've been saying nothing. So sorry. Whee! So yeah, that I just was showing. This is the Mechatrellis driver board that Steve put together. This is derived from the Adafruit NeoTrellis 4x4, and you can get all the files there if you want to make your own or just study it. It uses a Seesaw chip flashed with the same firmware. All that stuff is identical, and it's just a difference of having, instead of the conductive pad that the NeoTrellis has, the Mechatrellis has a footprint there for a Kale Chalk V1, a little low profile switch, that's what I'm using here, or the ubiquitous Cherry MX. And then the other thing I mentioned here, that's why I unplugged this, is that I 3D printed some keycaps that actually turned out great. And I've usually been highly dubious of 3D printed keycaps, but since these are flat, not trying to put any sort of curve or cupping to them like keys that you would type on, these are great for this type of, also for sample launching, finger drumming, that kind of stuff. Kale keycaps there aren't that many styles out there, and they tend to be a little more expensive, so I decided to go with 3D printing, and it worked out great. I just got those keycaps off of the Bamboo Labs Maker World, and then yeah, that was a pretty standard print. So only worry about those is that they could get snapped off inside of the little stem there, little pair of horizontal prongs that go on there, but I don't know, it doesn't seem that likely, and in that case I could probably fish that out and buy some. So anyway, that right there is what I'm working with. Andy Calloway said, I think John has his notifications turned off. Yeah, you're right. I kept I guess that's the downside. I turned off those beepy notifications. I should turn them on for just this channel, and then I will notice when you're screaming at me my audio is out. So that'll be for after the show. I'll try to get that worked out. Thank you. So that's what's going on with that. And yeah, let me know if you have any thoughts or questions. I am probably going to do a version of this kind of thing using our, we have a snap apart key matrix that I've used and other Adafruit people have used for some keyboard projects that are in the Learn Guide. Let me bring this up here. We call it NeoKey, not gnocchi. NeoKey, and it's a similar layout. It actually comes as a 5x6, which can be snapped apart. And so I may take these and do a little modified version of this. I think maybe just do like 10 by 12 or something like that. It won't be an even multiple of a typical music grid, but could be kind of neat. And obviously this has a lot more wiring involved compared to something that just uses the little I2C pre-routed diode matrix like the Mechatrellis. So, but that's what I know about that. And I paid my own money to buy these off of Steve, so there's no impropriety there. I'm not shilling for him. I just think that it's a cool product. So there you go. Right, next up, let's turn our attention to the Joystick project and where I'm headed with that. So over here on the workbench, let me switch that. So this, I showed this last week, but this is a inexpensive-ish, old, like 2007 era. I think it was a PlayStation 3, PlayStation 2-ish era fight stick. So if you're playing Street Fighter or something like that, this is a typical kind of stick to use for that. It's also good for arcade games, for a lot of arcade games. So this thing had terrible switches in it. It was a little conductive nub on the bottom of a arcade button, so I kind of think of it as like a fake arcade button. Usually an arcade button is a tactile switch of some kind. And since we have those, we have some nice 30mm tactile switches in the shop. I decided to pull these things out and wire that up. And I started showing just the mechanical side of that last week, but I wanted to jump into the wiring that I've got going and take you on a little journey with that and then see where that's headed in the future. So let me step over here. And I'm just gonna pull up my Discord here so that you can let me know if I do something silly like lose my audio again. There we go. So this had a very nice heavy steel plate at the base. That's what keeps that thing feeling hefty. And it has a nice enough joystick in it. The joystick is a real 4-way tactile switch joystick. But previously we had, where did I ditch the PCB to? Does anyone see it? Did I throw it away? I may have thrown it away. Yeah, I've got no use for it. I'm trying to get a little better about not keeping every last little piece and part. So this is what was in there with all of these conductive rubber switches pressing down on them. So that's how these contacts got closed. It's just a ground per button. They're tied together. And a unique pin per button, and then that goes to the little microcontroller chip that was on the base board there. So that is all this did. So I desoldered that. I put that in the trash. This was a little plastic piece to prevent flex, to provide some support. Since each button presses down on this, they didn't want this flexing over time, which is smart. By the way, May Flash I believe is the name of the company that made this. I think I made up a name like that, similar but not that, last week. So May Flash. That name shows up when I plug it into a Raspberry Pi. It's the only place I've seen its name show up, and I'll demonstrate that. But what I've done since last show, so I was showing off my little 3D printed socket drivers for the arcade buttons, and I didn't have enough of them to finish this off. So I ordered a few more buttons. I'm going to put those in. But you can see here what I did was I took we have some little crimp connector wire cable assemblies that have a little JST plug on one end. So if you're building a fully modular setup, just like they did on the joystick here, zoom in a bit, you can plug in, but I just cut those to an appropriate length, soldered them to this little permaproto board, and soldered in their ribbon cable that went to that PCB that I threw away. So this just allows me to a little more easily connect up to the microcontroller board. And I ran a separate ground to each just to make wiring easier. Sometimes you'll like daisy chain your ground around, but I was like, it's fine. I've got these double cables. I'll use those. So what I'm going to do is let's replace this green button here and this button that doesn't even fit over here. Oh. Yeah, this little 3D printed socket, this is the one that happy accident kind of grips the nut, which is great in this case when you're removing them. So I'll pop that out of there. Let's put this one in. And I should have probably, maybe I still will, label these wires just so that it's easier to not get them plugged into the wrong one. But some of that is dependent, there we go, dependent on if we keep this microcontroller in there or not, because we'll be able to assign pins to anything we want if we end up putting in a Pico or something. So there's one, and these are just a ground and a digital input pin, so it actually doesn't matter which one goes where. I've just been trying to keep them a little consistent. So the one on the right, which I marked with a little black Sharpie, is going to be the ground in this case. Sorry, just bringing that back. And then we'll plug this to the other pin. There are, we'll look at this a little bit, there are LEDs built into these buttons. They're just like I think a white LED that gets tinted by the plastic, so there's no RGB or anything fancy like that. But if we want, we could light these all up or have them interactive. I never find that to be all that interesting on a arcade stick, to be honest, but I may do it if we go with a Pico. All right, so here's my other blue button on here. I was going to go all blue, and maybe I'll do that just because it feels very PlayStation-y. And so I was saying last week, this this board, it's interesting because they've got PlayStation 1, PlayStation 2 controller, which I think is shift register, and USB. So they actually have two interfaces on there. And the USB one shows up on my computer. I'll plug it in. And something like controller tester, web pages see it and recognize most of the button presses, but some of them are really curious. There are, I think, 2 buttons of this set of 8 that you can tell have been registered because there's like a little timestamp thing that happens but they don't show up as any click. So those are kind of interesting. And I haven't researched that much, so maybe someone knows what some PlayStation buttons are doing there that are weird. Maybe one of them's the home button. Sometimes that's a really specific, bizarre one. Who's the ground? You're the ground. I don't think I marked this one. Let me mark this one. Okay. So I'll just show you before we even do anything to test this or plug that in. I'll show you what the LED lighting looks like. I've got a bench power supply here, currently off, but I'll give it 2.5 volts because I don't have a resistor there, and I need to fire up a resistor calculator to figure out what that resistor should be if we're giving it 5 volts from the USB. But here, if I turn that on, we'll probably see a little glow from this side. Let's see. Nothing. Are you... Yeah, they're plugged into the right ones. All right, let me put this up to 3 volts. There we go. So you can see a little glow there. And from the other side. Boop. I mean, it's fun, but you don't really look at those. So that's what those are all about there. And then I'm going to go ahead and put just 2 screws in of the base. As I was saying, 4 of these screws are embedded under the rubber feet, and I just used a razor to slash those and peel and pull the screws out rather than peel the feet up too much, because I fear they won't go back, and they're a fairly specific size. So here's my little bag labeled Joystick Base Screws. Look at me trying to be semi-organized here. Sometimes I just put a magnet on my workbench and clump these on a per project basis. All right, let's grab a Phillips. Okay, so let's, first of all, I'll show this in the controller tester on my workstation here. All right, let me set that there. And before I plug it in, let me bring up a controller tester website. So here we go, gamepad tester. So this says nothing is plugged in. It'll try to detect when a USB gizmo goes in. So it calls it PlayStation. So this may flash, put that name forward as the name that would show up there. And I'm gonna add, let's do this, and this, and this, and this, and that. Adjust my exposure a ton. There you go. So you can see, share that. You can see there's the buttons, at least on the joystick. So if I press button 2 here and button 3, those are acting like, what are they, square and circle on PlayStation. And then, or no, yeah, square, circle, no, X and circle. And this one's giving shoulder. This is giving triangle. This is giving nothing, nothing, shoulder, nothing. Now, if you look at the little timestamp section there, this is interesting because it knows an event happened, but it does not know what that event is. So that's some weird. That one's doing nada, nothing. That's getting something. So this controller is very, very PlayStation centric. So my Mac and this browser thing just kind of don't know what to do with some of it. Joystick on here does not show up until I hit this button combo that turns it into a D-pad. It can act like a fake analog pad or a D-pad, so that's again a little funny thing about the May Flash firmware on whatever that little chip is there. So what this all leads me to is, should I keep the functionality that's there, but add a second USB cable or a switch of some kind and put a Pico in there, or KB2040, and run the, what is it called, GC 2040, the game controller 2040, which is super cool and would allow it to then act as a switch controller, a DirectX Windows style controller, and a couple others. So that's one option. The other is that I do joystick gamepad from scratch, leave this as is, but I can do a project that's just, hey, if you've got a shoebox, how do you turn that into a joystick? I think we've done some similar ones, but not in a while, and I don't think with like the Pico anything that modern. So I think we probably had some old Arduino versions of that, or bonnets for Raspberry Pis. So yeah, if you have any thoughts about that, let me know. But I'm gonna do some joystick building. And then the other thing I just wanted to do was show it a little bit in action on, let's go to this view. So sorry, it's a little, I'm gonna turn off the one of the glares there. The other one is hard to get to, so I'm gonna leave it. But if I plug in the USB into Raspberry Pi that I've got over here, I hastily configured this in RetroPie in a way that I might not be able to get out of the game, but let's see. Let's see if we can. Let's see if the controls option in here. Settings, information. Core information? No, this is all MAME stuff. Okay, so let's go back. Quit. All right, yeah, so here we are. This is MAME. I can go between emulators. I could go fix the controller setup, but I think we might even see it show up here. Look at the bottom of the screen. Can you see that? Not that well, sorry. Did it see it? No, it didn't show. I think when I start a game, it will say, "Oh, I get your controller. Here's its name." So when I'm going to hit this, May Flash Arcade Stick configured in port 1. My Power Co. Limited. All right. So I did configure a coin drop and a start. I don't know if I didn't plug in audio cable off the Pi. But we have a nice, shield out. Yeah, we have a nice arcade stick here. Way smaller than the last one I put together, which was that giant double tank stick with a trackball in the middle, which I put away. It used to live over on the back wall there, but it's just too huge. But this is, hey, this is, let's see if I can get out of there. I don't even know what buttons those are. But this is working nicely for that. So could be it's a decent enough MAME controller because it does, unlike my Mac and gamepad tester, when I was configuring that, it saw all the buttons, I believe. I think so. We'll see. So that's what's going on with Joystick project. If you look here, I'm gonna pull up the is it GP2040 gamepad? GP2040 CE. Bring this back up. Yeah, GP2040 CE. I've used this on a couple projects. It has, so it's built around RP2040 chip. I don't know if it runs on 2350, but I don't think there's a need to. But you can see here it's compatible with PC, PS3, PS4, PS5, Nintendo Switch, Xbox One, Steam Deck, Mister, and Android. And I'm about to dive into Mister. I have a Mister-based PlayStation-looking gizmo on order. So Mister is a sort of multi-platform FPGA game setup. It's emulation, but it's FPGA, so it's kind of not. So GP2040 might be a good bet because then I can configure stuff, also LEDs. And one thing I haven't done with GP2040, which I kind of am tempted to, especially if I do a joystick from scratch, is you can put a 128 by 64 monochrome OLED on there over I2C. The one I showed the other day would work, or I could go for a bigger one. That's based on that SSD 1306 driver. So pretty cool to add that as well as some of the LED support so that you can have little config menus and things like that, like which mode am I in? You know, when you start up, you usually hit a button to say, okay, this is going to pretend like it's a switch. This is going to pretend like it's X input and all that. So yeah, that's the project that maybe I'll do that with. I think that as far as latency goes, that's the best bet. You know, we could do this in CircuitPython, we could do this in Arduino, but I think for the most authentic lag-free or at least lag available, this is the way to go. And you can do analog sticks and you know, a whole bunch of other things with them. So yeah, very fast pull rates and very low latency on all of these setups. So that's what I'm aiming for. But again, like I said, let me know. Okay. I mentioned there's another project that I'm about to kick off, actually a couple of them. One of them is the ES Spectre, ESP Ector, ES Spectre. It's a human detector using Wi-Fi CSI information. So it sends data, pings data back and forth to your router on 1 million channels simultaneously, not 1 million, but a lot of channels simultaneously. And it looks for changes in that signal that are based on human interference, so you being near an antenna. So there was a really cool project that uses that with like ESP Home to say, has someone come into a room in a case where it's inconvenient or not practical or possible to use other types of detectors, you can use an antenna and interference to tell. So I'm working on that with the ESP32 Feather, and then I've also got, let me see if I can find this link. There's a pretty cool one-button Bluetooth keyboard project out there that was a Kickstarter a couple of years ago, and it looks like a good candidate, Lamore mentioned this, it looks like a good candidate for a remake using a little cutie pie. For some reason I thought I had the link here, but let me just do one button keyboard. Yeah, it looks kind of like those, but wireless. Let me add the word Kickstarter since it was one. Mono key. That's what. So I think this one might use BLE, but we can do classic Bluetooth on the ESP32 Pico chip, CircuitPy. So this is a really nice form factor, and I'll see if I can make something like that. It'll probably be a little thicker because we have some BFFs to stack for the key switch and for the power to be LiPo powered. But it looks an awful lot like a CircuitPy kind of project. In fact, I think if you look at the little cutaway animation here, hey, look, it's probably a Xiao in their ESP32 C6 Xiao, I'm guessing. So I'll do a little remake of that. If you want the beautiful, nice one, then go to this Kickstarter and see if they're still selling them. I'm not sure if they are. But if you'd like to make your own and hack on it, then I'd like to offer a Learn Guide to help you with that. So, oh gosh, I'm so sorry I'm not showing this. Here it is. Yeah, so this is the mono key. That's what that looks like. And if you look at their little animation here, you can see the stack up that has a little key switch, holder, Xiao looking thing, battery. So I think we can put together a decent approximation of that. Funding period ended October 2024. Yeah, I don't know if this is still something that exists or is for sale, but we're going to do our own version. So was I not showing this? I may have switched around. I can't remember, but this is GP2040 CE, which is the firmware that we can put on a Pico or KB2040 to do the arcade stuff. All right. I think that's going to do it. Before I go, I'll remind you the coupon code today is CALIPER, so if you'd like to save 10% off in the store, head on over to Adafruit.com and throw some stuff in your cart. And it's got to be actual things that we can send to you and work on gift certificates, software, or subscriptions, but that will get 10% off on whatever you buy. Also, we do still have some enticements for spending more. It's what keeps the lights on at Adafruit, so buy stuff. But if you want to go to adafruit.com/free and get rewarded for buying more stuff, then these are the enticements we have. If you spend $99 or more, you'll get the free Adafruit PCB coaster. If you spend $149 or more, you'll get the coaster as well as a KB2040. And at $199 or more, if you're in the continental United States, you can get free UPS ground shipping. All of those stack, so you'll get all three of those if you go to the $199 level. All right, that is going to do it for me for today. Like I said, I will not be doing the Tuesday product pick show. I'll be out of town. But check out Scott with a deep dive tomorrow. Foamy Guy, I believe, is doing a deep dive on Saturday. And then there will be a 3D Hangouts Wednesday morning and show and tell on the evening. And we're still waiting to see what Desk of Lady Ada and Ask an Engineer and pre-recorded videos are possible, given all of the cold, illness, new humans, etc., that we're still digging out of from the new year. So that will do it for me, and thanks again, everyone, for hopping over into our chats. Oh, my Discord just rebooted, so let me see. Were there any important messages? Oh, my gosh. Oh, nothing urgent. Okay, good. So, yes, and Andy Calloway tried to close the ad by clicking it when I was showing the gamepad tester, I can imagine. M5 Stack has 1 and 2 button module. That's interesting. I should check that out. Thank you. Thanks, C. Grover, Andy Calloway, Hesitant Road. Thank you very much. And thanks for everyone over in the YouTube chat as well. That's going to do it. I will see you soon. Thanks, everyone. Bye-bye.